myself on this screen, and my name, and which is there already. I've been an amateur astronomer for 45 years, and I'm a member of the American Association of Variable Star Observers. And obviously, through Alistair and I met on Facebook, and I saw him posting about a need for doing something like this. I said, why not? It sounds like a lot of fun. So, so let's get on with it. Okay, so what is a variable star? We'll cover a few basics. Well, it's a star that varies in brightness. And astronomers use the term magnitude to describe the brightness of an object. And in a variable star term, a star is at minima when it's at faintest, and maxima when it's at brightest. And the difference between the minima and maxima is a term called amplitude. It's just a difference. So the graph you see here on this slide is what they call a light curve of a variable star that's changing in magnitude over time. And from trough to peak would be the amplitude, and the time from one peak to the next, or from one trough to the next, would be the period of the variable star. And that period can be anywhere, depending on the type of variable star, which I'll get into types later on. The period can be anywhere from a few minutes to years, if not decades. And next slide. So now astronomers observe and study variable stars to get an idea about their various properties, such as their mass, radius, etc. And we use that data to increase our understanding of the universe in general and stellar evolution in particular. It was less than 100 years. This is really interesting. This blew me away when I first got into astronomy, and when I started doing variable stars about 10 years ago. This little tidbit came to my attention. I'm just fascinated by this, that it was less than 100 years ago, in fact, just prior to 1923, that we did not know the true size of the universe. We thought our entire universe was composed just of our Milky Way galaxy. It turns out that all those little faint nebulous or cloud-like objects that you see in your telescopes, that we were seeing in our telescopes, are separate galaxies outside of our own galaxy. We didn't know that prior to 1923. And it was through observation of a particular type of variable star that enabled humans to figure out and determine how big the observable universe really is. So that lots of value. Now, if you're wondering if variable star astronomy is for you, I'm going to share this lovely quote by William Tyler Alcott. He was the founder of AVSO. And it says, "It is in fact that only by the observation of variable stars can the amateur, from his modest equipment to practical use, and further to any great extent the pursuit of knowledge and its application to the noblest of the sciences." Now, the amazing thing about this quote is that it was written before 1923, before we knew how a variable star would tell us the true size of the universe. And to this day, thousands of citizen scientists that happen to be amateur astronomers like you and I continue to observe and contribute to the science of astronomy through variable star observation. So now you know what a variable star is, or what they are, and how useful they can be. It's pretty clear that there's tremendous value in observing these objects. So let me introduce you how you can get started. I'm going to show you the rest of this presentation. I'm going to show you how to select a variable star that you may have an interest in observing. And the list of stars you select will become what they call your program stars. Then I'm going to show you how to find your variable star targets with various tools at your disposal. I'll show you about that too. And when it comes time to observing a variable star, I'll go over how to pick what they call comparison stars, or comps as we call them. Comps are stars that don't vary in magnitude, and they are used as references to compare and estimate the magnitude of the variable star at the time of observation. And to make sure all your hard work was worth it when you observe these objects, I'm going to go over how you can report your observations to various organizations. Now, if you didn't know it before, there's nearly 1.5 million variable stars known. And now, of those 1.5 million, many things aren't known about them. For example, there's many thousands of stars, tens of thousands actually, we don't know their period. We don't know their minima and maxima, for example. And there's many more discoveries to come with these large surveys that are going to be taking place. Literally a zoo of stars to observe visually. Now, you may have learned about some of those large surveys that have begun or about to begin. One is called the Large Synoptic Sky Survey, or LSST, which will observe and record the entire sky every 3 nights. That's a heck of a lot of data. Some observers, visual star observers, thought that these large surveys would spell the end for the visual variable star observers, and nothing could be further from the truth. The visual astronomers and the work coming out of the surveys will complement each other. And by the way, these surveys have their limitations. Their CCD cameras on the telescopes will saturate, meaning they can't observe brighter stars. 16th magnitude stars is their upper limit. They can't look at anything any brighter than 16th magnitude. And these surveys can't observe any particular star with sufficient frequency. Recall I was telling you about how variable stars can vary on the order of minutes or hours. Well, this is every 3 nights. And that's where the visual astronomers come to the rescue. So, having said all this, forget about what I just said. I just want to give you a little bit of background, but at the end of the day, you do make sure you're having fun knowing that you're contributing to science in your variable star observations. Now, before you select what kind of variable star you want to observe, consider that there are over 200 kinds. They're categorized into groups, then classes, then types, as you see here. A few of the types are broken out in recognition of their additional characteristics or properties. I'll be showing you a resource to read up on the differences of variable stars later on. Now, each type of variable has a story to tell and is a piece of the puzzle of how stars are born, how they live, and how they die. For example, over on the extreme right, you'll see a subtype called Miras. Mira variables are giving us a glimpse of what the future holds for our sun. One day, our sun will become a red giant, and it'll become a pulsating Mira, or LPV, long period variable. So studying Miras gives an example of what our sun might end up being like. And it's important to recognize that every star was a variable at some point of its life. When it was first born, it was a young stellar object. Has different stars, depending on their mass and other properties, have different variable type properties as they live through their lives. And they die. When they die under different circumstances. And that determines how they vary as well. And even our sun, at right now, as humankind is alive, our sun is in fact a variable star. So let's see why we need to observe variable stars to advance and expand our understanding of the universe and stellar evolution in particular. So what should you observe? Well, like I said, there are over 200 kinds of variable stars. The trick is to ask yourself, what types do you want to observe? I have some experience observing variable stars for about 10 or 11 years now, but in talking to many more variable star observers with more experience than I have, they come to the conclusion that you'll be drawn to your favorite kinds of variable stars. So to start, you should go over to the American Association of Variable Star Observers website. I just want to mention too that the British Astronomical Association, they have a variable star section, and they have very similar resources there. But being a member of the AVSO, I'm more familiar with their resources, so I'll be going through the things that they do there. So I'm checking my notes here, making sure I got this right. Okay. So types of variable stars. So I'm going to bring up my browser because this is the way my presentation was. So hopefully this will work if I bring this over here. Do you now see a web page? Hello? Oh.
Yeah.
Oh, you do see it. Okay, very good. Thank you.
Yeah.
I just want to make sure you're seeing what I'm seeing. Good. You see a web page.
Yeah.
Wonderful.
Yeah.
Okay.
AVSO.
Okay, good stuff.
Yes,
so,
I see it. Yes.
This is the home page of the AVSO. So if you see my cursor, you'll see under the Observing tab, I'll go down. Sorry, wait a minute. Not that, the Variable Star tab. The Variable Star tab, you scroll down here, it says Types of Variable Stars. And this page is a generalized description of the types. Now, it's a very high-level page. It's very summarized, a bunch of light curves there talking about different types. But at the very bottom of the page, you'll see a link here called Variable Star Types with Main Groups. This is a very lengthy document. It's incredibly dry reading. You've been warned. But it gives you a tremendous insight into all the subtleties of the variable star types. Now, another thing I want to show you, and you can download this document and read it in your leisure. The other thing I wanted to show you at the association's website under variable stars as well, near the bottom, if you scroll down here, it's called the Variable Star Index, or VSX. Now there you can search by type of variable star. We'll hit the search button and we'll put a star in here called Z Ursa Majoris, ZUMA. And if I hit, you can hit the search button here and you'll be presented with all manner of detail about the star, and there's additional further web links where it'll take you to other resources and whatnot. Notice here at the top, it says there's been almost 106,000 observations by the astronomy community, mostly by amateur astronomers. This is a very interesting star. It's semi-regular variable class, and its spectroscopy is M5, so it's quite red. And the magnitude range is 6.2 to 9.4. So a very easy star to observe for those even with binoculars. Another resource, go back here under community, there's the discussion forums. Now, this is one aspect of the website where you need to be, you don't have to pay or even become a member or anything, but they want you to create an account at the website so that you can post questions or whatnot to the variable star section forums. And if you don't want to do that, all you can do is view the responses, and you can't post. But down here in the section is a section here called variable stars, and these are pretty broken down by the major groups of variable stars, groups and classes. And there's a wonderful bunch of folks here that can really lend a hand if you need help to do that as well. One other thing, two other things actually, is under observing, scroll down over here, called alert notices and observing campaigns. Now again, you have to register with the website. That's because they need your email address. The wonderful thing about alert notices is that here you get to work with professional astronomers. So a professional astronomer will contact the association and say, we need help from your observers to monitor such and such of a variable star. So this alert notice will be sent to you through an email list. You'll get the notice and all the particulars from the professional astronomer, how often you should observe it and whatnot. So that's pretty interesting and fun way to get involved with some science with the professional astronomers. Lastly, here there's what they call the observing sections. And these again are pretty much broken down by the kinds of variable stars you want to observe. So there's a long period variables here, the cataclysmic variables, that's my specialty. I'm in love with those guys. Short period pulsating variables, eclipsing variables, down here, young stellar objects. There's also a section for the sun, so for solar observing. And these other three ones called spectroscopy, exoplanets, and high energy network. They do great work in their own right, but really they don't cater to the visual variable star observer. They're more for the CCD camera crowd. Okay, let's get back to my presentation. We talked about that. Okay, next slide. Okay. Okay, next slide is selecting targets, things to consider. So basically it's broken down to two areas, you and your target. So for you need to think about the equipment you have and your eyesight, because as we know, as we get older, our eyesight changes. Your observing location, are you in a rural area or are you in a downtown major city? And what's your commitment time to doing this? For your target, think about the amplitude or the difference between the variable star's brightest and faintest magnitude. A star which has an amplitude less than 0.1 magnitude. So if a star varies, say, from 7th to 7.09, you're as a visual observer, you and your eye, you just cannot discern such a small difference. So when you're selecting variable stars to observe with amplitudes, make sure you pick those that have an amplitude of at least 0.1. And when you're starting out, even bigger than that, because you need to practice to learn to see the difference in the magnitudes. Forget about the magnitude range of the star from its brightest to its dimmest. If you want to trace the star through its full light curve, make sure you and your equipment can see the star when it's at its dimmest, if that's important to you. And think about the period of the star. Some stars take hundreds of days to go from minimum to maximum brightness and then back again. So that's quite a commitment. Now, you don't have to observe all the time, but if you want to trace your own personal light curve for any particular star that has a period of, hundreds of days, that's quite an undertaking, and perseverance is the rule of the day. Now, other stars will just change in, like I mentioned before, just a few minutes. Now, the last thing you want to think about is consider observing semi-regular or irregular variable stars. I mentioned in the variable star index, a lot of those they don't even know the periods, and they often turn up some very interesting surprises, new discoveries for everyone to be had. Now, here's something that's quite useful at the website that I want to show you as well. It's called the AVSO Target Tool. If we go to the site, and under observing, you'll go down to Target Tool, hit the big blue button, and it'll take you to this Target Tool. What it does is it basically gives you a semi-real-time view of who's observing what around the planet and when it was last observed. So it has all these across the top, all these variable star types, at least in the major categories. And I'm going to do is just leave the long period type on for now. And then if I click this button to filter my observations, now I'm just showing only long period variable types. So the information here gives you the star name. In this case, the first one here is RU Andromedae. Gives you the position and right ascension declination and other information here. Its type and a minimum maximum magnitude. This one goes down minimum of 14.5 magnitude. So that would be quite a tough one to observe, even with a modest telescope. It also gives you the period, the observing cadence and whatnot. Now let's go over to the column. If I click on last observed, I can resort the column. It tells me when these stars were last observed. So what's important here is that you'll want to get on to observing stars that are flagged with these red boxes, because we need more observations for these stars. So you can see there's a lot of work to do here. So the other thing this tool allows you to do too is, because you can sort by any column, you can then make it particular to your equipment, how faint you can see in your magnitude. So it's just another resource to help you pick what kind of variable stars you would like to observe. Okay. So using the next set of slides, I'm going to show you very briefly a selection of light curves of, just generally give you, just a general, the differences in variable stars. I'm not going to spend a lot of time on describing each one in detail. Just want to illustrate the tremendous variety of light curves, if you will. So Cepheids have, the first type I got here is Cepheids. The prototype for Sol Cepheids is a star called Delta Cepheus. And it's a great beginner star, even if you're starting out with binoculars. Really quite bright, and quite easily to discern from, say, 4.5 to third magnitude. And the period is quite short enough that you get a lot of gratification observing the star just in a few nights. Then we have the long period variables I talked about. Now, why I want to bring these up is only because they're quite the favorite among variable star observers. Their periods are much longer, and they exhibit regular or semi-regular periods. And nice thing about these is that you only need to observe these types about every 5 or 10 days. Because they change in brightness so slowly, there's no point in observing them every night. Every 5 to 10 days is plenty. So cloudy weather is not much of a hindrance. You can always, make sure you have a clear night every 5 or 10 days. You'll just be fine. Now, supernovae are fun to observe, especially as you try and monitor their decay in brightness. And yes, supernovae are a type of variable star. Now, there's resources on the web to notify you of when supernovae occur. And you can join in with monitoring the change in its decaying magnitude. This slide here shows the famous supernova that was in one of the Magellanic Clouds in the Southern Hemisphere. I can't remember which one, but it was discovered when it was probably around fourth or fifth magnitude, it got to almost second magnitude. And then a bunch of observers, these dots represent observers from around the planet observing the decay of the light curve. And you can see how it slowly decayed until the 14th magnitude. Very interesting way to contribute to variable star astronomy. Now, unlike supernovae, supernovae result in the destruction of the star. They blow themselves to bits. They're dead, gone forever. Novae do not. Novae, or recurrent novae, is a system of two stars, and you'll see like in the lower right there, two stars where the primary is a white dwarf, a very dense star, and it literally feeds matter off its companion, its orbiting companion. The companion is spinning around the white dwarf. And every now and then, enough of the orbiting companion's star matter, which falls onto the white dwarf on an accretion disk, that matter builds up on the accretion disk to enough temperature and density that a fusion explosion results. And the star will go Nove or nova. And they happen to do this quite often, depending on the type of star. And they can show a huge change in brightness over time. But the important thing to remember here is that the system, the binary star system, is not destroyed. And you can see the light curve here a couple of times when the spikes here show when it did go supernova, or sorry, not supernova, when it went nova. Now, some observers regularly patrol recurrent nova. And these variable stars are normally dim, but every now and then, like I said, and sometimes with predictable certainty, they will flare up and brighten and go into outbursts. We call these things outbursts. And it's kind of fun returning to the same set of novae in your observing program. So if you have 10 or 12 novae in your observing program, and after many nights of observing them and being disappointed, saying, oh, it's still dim, you'll come across one night and you'll be pleasantly surprised, oh my goodness, RS Ophiuchus is in super outburst. And there's a chap in Australia, his name is Rod Steubings, and just a few nights ago, he recently observed 242 of these novae, recurrent novae, in one night, 242 observations in one night from his monitoring program. And he detected 15 outbursts just in that one night. And just to let you know, Rod normally does observe, 100, 200, 300 stars in a night. So he's quite proficient in observing. Lots of fun. Z-Cam stars are truly intriguing. Again, these are like recurrent novae, but they will brighten and dim and go through what is called a standstill, as you see on the screen there on the light curve, just next to that blue arrow. It just completely flatlined. And interesting, all of these Z-Cam stars, when they do go into flatline, they stay at a magnitude which is approximately 1/3 of their maximum magnitude, and no one knows why. So that's why it's important to discover these or to study these stars. Now, some Z-Cam stars have been incorrectly classified as Z-Cam stars over the years, and the AVSO has a campaign and a project to weed out the Z-Cam, what they call imposters. So maybe something you would like to join as well to weed those imposters out. Now, of course, just to make things even more interesting, we have what they call the reverse novae. And remember I talked about how a novae, like a supernovae, is like, very dim, then it goes bright. Well, this is the complete reverse. This is a star, and the arc coronal borealis is the prototype for all what they call reverse novae or eruptives. And they stay at a brighter magnitude, and then every now and then they'll suddenly go very faint. And it all has to do with a shell of stellar mass being ejected from the star, interacting with the interstellar medium. And the star is being obscured by the expanding shell of dust and gas. And it can be a very slow process to recover from the faint state as the shell dissipates into the interstellar medium. So observing these stars can detect sudden drops and rises in magnitude, and that's a great project in itself. Another favorite among variable star observers are eclipsing kinds. Of course, Beta Persei or Algol is a prototype that was known to vary even in ancient times. And Algol is a period of just over 2.8 days, and the variation is visible even without binoculars or telescope. You just need your eyes. Now, in eclipsing binary systems, each star orbits the other. As one star eclipses the other, the system changes in brightness because the orbital plane of the system is in our line of sight, is in line of sight with the Earth. And monitoring the timing of mid-eclipse reveals much about the evolution and properties of these binary star systems. Now, we all know that stars rotate, but this type is characterized by rotating into view of very large star spots. Yes, these are like our own sun's sunspots, but much, much larger. As the spots rotate to the Earth side of the star, the total surface brightness of the star fades appreciably. In effect, you could estimate the rotation period of such a star by monitoring the change in magnitude. And finally, as I mentioned before, don't forget about the thousands of irregular variables. Many do not have a defined period, but they do vary. And these stars are very poorly studied, and observing them could produce some very interesting results for the professional astronomers. So what do you need to find variable stars? What can you use? Well, first of all, get yourself a good star atlas. Many star atlases show a very good selection of brighter variable stars. You can also use a computer planetarium program on your laptop or desktop computer. And there are also some planetarium apps for smartphones and tablets that include variable stars. I didn't find too many though. Now, also a pair of binoculars becomes very helpful in getting yourself acquainted with the broader field of view where a particular variable star is located. Binoculars give a correct left, right, and up-down view that matches the star atlas view, so it makes finding variable stars much easier. So let's have a close-up here of what we talked about before with Z Ursa Majoris, and it's a variable star, a semi-regular variable star. It's in the bowl of the Big Dipper, Ursa Majoris, and it's just off the tip of the pen here, shown in this slide. But wait, we need some comparison stars or comps to make the observation. What do I use? I mean, I can't use the stars, or a lot of these stars aren't here, have no values for the magnitudes on them. So I need a different resource. So that's where AVSO comes in handy again. So what you do here, you go to, let's see, come on, let's go right here. Okay, go to the variable star AVSO website again. Under observing tab, there is a selection here called variable star charts, variable star plotter. I've pre-populated this form already, but what you can do is you can put the variable star name in here. We put in Z Ursa Majoris. I want a visual chart, and my field of view is going to be 300 arc minutes, or 5 degrees. That's typical for some binoculars, and we're going to be doing a binocular observation. I set my magnitude limit for the chart to 12, because I can't see anything fainter than that with my binoculars anyway. And you can change some other things on the form here. I'll let you go and explore that on your own time. Have fun with that. And we just click the blue button that says plot a chart. And very quickly, let's see, a chart is returned. And if you click on the chart itself, you can get a magnified view. You can print off this chart, or you can save the chart as a digital file to your laptop or whatnot and take it into the field with you. On the chart itself, the center you see the crosshairs, that's where the star is located. Now they don't show the star because we don't really need to see the star on the chart. We just need to know where it's located. And they don't want to add more confusion. And then there's these other stars on the chart with whole numbers on them. For example, 84, 87, 99. Really, these are the magnitudes of those comparison stars. So 84 is in fact 8.4. 87 is 8.7. And so on. They remove the decimal points because you would confuse the decimal points with background stars, and that would just create another problem. So just bear that in mind. In the upper left-hand corner, you see the star name, its magnitude range, its period, 195 plus days, its type, and its spectral classification. And over on the upper right, you'll see the chart ID, sort of a cryptic number, X25, and so on. Remember that chart ID because you're going to need that to report your observations. So the next thing I want to show you is picking comparison stars. Bring that. Okay. So when you pick comparison stars off your star chart, here's just a few tips. You want to use at least 2 comparison stars or comps, and you want a couple more if possible. Don't, at least 2. You want to bracket the target magnitude, meaning you want to pick a comparison star a little bit fainter than the variable star as you see it right now, and a little bit brighter than the variable star as you see it right now or during your observation. And the other thing you can try to do, sometimes it's quite difficult, is the magnitude interval between the comparison stars, the 2 comparison stars, shouldn't be more than about 0.1, 0.5 magnitude. That's quite difficult to achieve sometimes, but do the best you can. And here are some tips to estimate the magnitude of the star, the variable star itself. You always want to make the observation with a clear head. Don't listen to your buddy saying, oh, I saw Zeta Ursa Majoris an hour ago and its magnitude 7.2. Don't listen to these people. You have to go with a clear head and unbiased observation. Then don't let your observation be biased by what you think. That's what I'm trying to say. Then make sure the target and the comparison star is near the center of the field of view of your telescope view. And think about the target and comparison stars. They should lie an imaginary line connecting your left and right eyes. You may have to tilt your head one way or the other, but that's what you want to do. Rather than have a comparison star above or below the variable star, rotate your telescope or rotate your head so that the comparison and variable star are connecting your left and right eyes. And beware of a thing called the Purkinje effect. The Purkinje effect is that red stars will appear brighter the longer you stare at them. This becomes very important if you are looking at Miras or long period variable stars, because some of them are very red. So don't stare at the star in making your variable star magnitude estimate. You just make a quick glance of the situation. And you may take 1, 2, 3, a dozen glances to try to determine the period, but just don't stare, because you'll get a wrong magnitude estimate for the variable star as it appears to brighten from the Purkinje effect. Now, to report your observation, you'll need to provide the following bits of information. The star name, we talked about one already, Zeta Ursa Majoris. The date and time, that could be the Gregorian year, month, day, or the Julian date. You can use a Julian day calculator. There's a Julian day calculator available at the website. Lots of planetarium desktop programs can provide you the Julian date. So you'll need the date as well of the star name. The magnitude estimate. So I looked at Zeta Ursa Majoris, and what is the magnitude estimate that I came up with, that I observed? What were the magnitudes of the comparison stars? Those are the published magnitudes that were on the variable star chart. Then I need that very important chart ID from VSP that we talked about. And then you can also put in any AAVSO supplied comments. These are codes. You'll see them on the right there. So if you're observing during a full moon or you had light pollution or whatnot, you would put a comment code of B. If you're observing with poor seeing, the atmosphere was very turbulent, you put a comment code of W. And the last thing you can do is you can put a few notes in there for yourself, like, having fun doing it or whatnot. You can just be brief about the notes, though, but they can be useful to others when you're in your observations. Now, to report your observations, all you need is something like a very simple spiral-bound ruled notebook is good enough. Some observers use a spreadsheet on their laptop at their observing station immediately at the time of observation. Use whatever works for you, but here's just a typical example of what an observing log would look like, for the important information you need to gather for your observation. And to submit your observation, if you do submit your observation to the AVSO, you're going to need what they call an observer code. All you need to do is register with them. You don't need to pay them any money. You don't need to join. You just say, I would like to have an observer code. My observer code is CMJA. And they need that observer code so they know who is observing what. And that's how they keep track of all the observations. And you'll go to a thing on the website called WebOps and to submit your observations individually. But if you don't want to do that, if you put your observations in a spreadsheet and convert it to just like what they call a comma delimited file, or CSV, it would be structured like this. So there's some header information at the very top here of the file. It would be, and it's all preceded by hashtag. So hashtag type equals visual, meaning I'm making a visual observation. Hashtag observer code is there's my observer code. The software used, well, I happen to just compile this in Notepad, for example, no big deal. The delimiter, is a comma, meaning what separates the bits of information of my observation. The date, I used Julian date. And then the last one here is just the column or data headers, if you will. So the name, date, magnitude, comment code, the comparison star 1 and 2, and its chart, and my notes. So in this case, it's star Z Ursa Majoris. There's the Julian date. I estimated at magnitude 8.5. An observer code is W. There was poor seeing that night. My two comparison stars were 84 and 87, meaning those were the published magnitude values of 8.4 and 8.7. There's my chart ID. And my note to myself is, hey, it's my first observation. Now, the website itself has a way, like I said, you can enter your observations individually. If you have dozens of observations, this is not a good way to do it. You should use what I said before, put them in Notepad, and you submit a file of observations. But there is a form there. If you just did one observation tonight, say, you could go and put in the star identifier, the name, and all the information I was talking about, and hit the submit button, and you're done for the night. But you can see how good record keeping is important. But what I talked about for using Notepad is this is the other way to do it. And you'll go to this part of the website. It says upload a file of observations. And you'll hit the button choose file. And you'll just use a file off your hard disk. That's the Notepad file, your comma delimited file. And you pick that off your disk. And then you hit, once it's loaded on the web page, you say upload the file, and you're done. It's a great, wonderful, efficient way to upload, dozens or if not hundreds of observations at once. So for further reading, and I'm almost done here. So for further reading, I highly recommend these titles. One is Understanding Variable Stars by John Percy, Observing Variable Stars by Jerry Good, Observing Variable Stars, Nove and Supernovae by Gerald North. And a really interesting book is on light curves of variable stars. It gives a very pictorial atlas and description of light curves. And that's by Sturkin. What else we got? Finally, if you go to the AVSO website, make sure to help yourself to the Manual for Visually Observing Variable Stars. It goes into much more incredible detail than I can do here in 30 or 40 minutes. It's a very good read, lots of good graphics, and you can download that manual as a PDF. Now, like I said, I was speaking a lot about the AVSO, mainly because I'm most familiar with the organization, but there are other organizations across Europe, in Belgium, in France, in the UK, that study variable stars as well and report on them. An example I mentioned was the BAA, and they have a tremendously active variable star section. And like I said before, there are many aspects of the BAA variable star site that's very similar to AVSO, such as variable star observation programs by type that you can explore. So just take time to observe or browse what BAA has to offer as well, because it can be very complementary to the AVSO information. So I'm going to conclude with another quote. This one was from Leslie Peltier, Leslie Peltier's book entitled Starlight Nights, The Adventures of a Stargazer. Some of you may know about Leslie. He was a prolific variable star observer. And his quote goes, "I feel it is my duty to warn others that they approach the observing of variable stars with the utmost caution. It is easy to become an addict, and as usual, the longer the indulgence is continued, the more difficult it becomes to make a clean break and go back to normal life." Leslie passed away in 1980, but he was an incredibly prolific variable star observer. And like Leslie, I'm an addict as well when it comes to this. So, you've been warned. That pretty well concludes what I wanted to share with you today. If you have any questions, please do not hesitate to contact me through my website, which is shown there. There is a contact button on my website that you can leave me a message, and I'll try to get back to you as soon as possible. And that's all I had to say for today. So thanks for your attention. Take care. And if there's any questions, I'd be more than happy to answer them.
Okay. Well, thank you for that, Michael. That was very informative. Not something in astronomy that I've investigated much myself, to be fair. I think from my perspective, I've always found it difficult to kind of guesstimate the magnitude of stars, but that's said and done. I don't think I've ever actually tried. But very informative talk. I feel I should say as well, I do apologise for the under attendance here. I think one of the reasons for this might be that there's a BAA meeting running parallel to this.
Okay.
That is also, I believe, on variable stars. I had no idea on that. That was Andrew Wilson who told me, and he was wanting to see this one as well. But I'm wondering if that's why these aren't attended too well, is because of the BAA meeting runs parallel. I don't know when these are running. Obviously, I know David Eagle does something on Tuesday and Thursday, so I choose not to clash with that. But anyway, Robert, have you any questions, mate?
No, because as I was thinking of questions, Michael was answering them in the next thing that you were saying.
Oh, good. I'm glad I could answer your questions as I'm doing it.
Yeah, no, because I was looking as I was going through, and I was thinking, oh, I'll ask that, and then you were just going through and answering the questions. So a very good presentation. Thank you.
Thank you very much.
And I'm afraid that pretty much echoes it for me, Michael. I've been sat here with the notepad on my iPad, typing out various things I could ask, and as I was mapping them out, you actually went and nuked them as I went on. So one of the few I've watched actually where every single question you could actually ask has been answered. So you've covered all the bases there, mate. Thank you.
That's good. Well, I was a little concerned about I might be going overtime here, so we did two things at once.
No. Timing's perfect. I mean, we're just about approaching 2,000 hours now, but I mean, we're not exactly inundated with members. I think a few people thought to pop in and then popped out. But fair enough. I did DM them to ask if there was any problems, but some got back and some didn't. But never mind. But anyway, Michael, I have recorded this. So what I'll do, if it's okay with you, I'll put it up onto our YouTube channel. So those who couldn't make it at least get to see it. But thanks again for doing this for us, mate. Very grateful to you.
Keep in touch.
Thank you very much, Michael. Much appreciated.
You're quite welcome, and please stay in touch, and clear skies to you all, and have a good day.
Thank you very much.
Okay, thanks. Right.
Yes.
Bye.
Thank you. Bye.
Bye now.